Let's start with question number 28. The magnetic field in a region given by something B equal to B naught into x by a k cap. Square loop of side D is placed. You need to find out the EMF induced in the loop. Let's check. This is a portion. This one is dx. So area of this one will be, now flux through this one will be B naught xa into area will be d into dx. Okay, this loop is moved with some constant velocity. Okay, let's say this will be the flux. X square by 2. Now if you differentiate this one, you will be getting d phi by dt b naught d by dt b naught d by 2a x square. So 2a x square is dx by dt, that is v into 2x, and x limit is how much? For this side this is d, for this side the difference between this side is d, so you will put a limit 0 to d, you will be getting d. 2 to get cancel out, so you are getting option 4 is your answer, b naught v square d by a. So a question given as a copper rod of mass m slides under gravity on two smooth parallel rails with separation L and set to an angle theta with the horizontal. At the bottom rails are joined by resistance R. So here is the options. There is a uniform magnetic field B normal to the plane of the rails as shown in the figure. The terminal speed of the copper rod. So whenever the rod will attain its terminal speed, that means the total force will be, the net force will be 0. So I will be just doing this thing. I'm just drawing its front view. So let's say B is along this direction. Okay, so you need to find out the value of terminal speed. Okay, so this is mg, this is theta, then this will be mg sine theta. Now if you assume that B is along this direction, then I is along inward direction, then you just apply your right hand palm rule or left hand rule. So B is inward, then B is along upward direction, I is inward direction, so your force will be along this direction, right? This will be BIL, and its component along this direction will be BIL cos theta. Now mg sin theta should be equal to BIL cos theta. Now you need to find out the velocity. I is equal to what? as it is moving in terminal velocity, so I can be written as BLV by R. So now you can just put at this position and see the values which is coming. BLV by R into L cos theta. That means you are getting V equal to mg R tan theta by B square into L square. So if this B is along this direction, then you will be getting this one answer. But if you change the B, according to the question, the B is perpendicular to the plane. So in that case, what will happen? In that case, there will be no BIL cos theta. This BIL will be along this direction only. So this cos theta you may cancel out. So in this case, BIL will be in this direction only. So you just need to write BIL is equal to mg sin theta, and from there it will be sin theta only. But if B is along this direction, then the earlier answer would have been correct. In the given question, there is a bar magnet passing through a conducting loop of radius r with velocity v. The radius of the bar magnet is such that it passes through the loop. The induced EMF of the loop can be represented as you know that E equal to minus d phi by dt. So whenever this loop will be passing through this bar magnet, the flux in it is increasing. So E is equal to minus d phi by dt. This one will be positive, so E should be negative. So initially it will be starting from the negative position, and as long as this is inside this tube or inside this bar magnet, so at that time there will be no induced EMF, as the EMF as a flux is constant. So initially it will be negative direction, in the mid section it will be 0, and whenever it will be coming out, flux is decreasing, so EMF will increases. So this will be your correct answer. In a damped oscillation, the equation is for this question number 38. There is a thin strip of 10 cm U-shape where current with a spring of swing constant 0.5 Newton per meter. The assembly is kept in uniform anti-field of 0.1 T. If the strip is pulled from the equilibrium position and it releases, the number of oscillations performed before its amplitude decreases by a factor of E is N. If the mass of the strip is 50 gram, its resistance 10 ohm and air drag is negligible, N will be close to. So this is a strip. For this strip, the length is 10 cm. Now you know that this is a case of damped oscillation, and for damped oscillation this is the general formula, and this is the formula for the amplitude after time t, x equal to ae to the power minus rt by 2m. So now if you write this one, m d2 x by dt2 plus b il plus kx, so d2 x by dt2 is a b il I, you can write bl v by r. So this is b square l square v by r plus kx. So this one will be x equal to a to the minus b square l square by 2mr. If you compare these two, this r place is occupied by this one, and m will be written as it is. So in place of r, you are writing b square l square by r. This r is resistance, and this r is the damping factor by 2mr into t. So as it has been said that it is the amplitude decreases by a factor of e, so that can be written as a by e, a to the power minus b square l square by 2mr into t. A get cancel out, e to the power minus 1 you can write this as e to the power minus 1, and these two minus get cancel out. So 1 equal to b square l square by 2mr into t, and just put t equal to 2mr by b square l square, and you will be getting answer 5,000. T will be your 10,000 seconds. But you need to find out the number of oscillations. So for number of oscillations, you first need to find out the time period. So the time period will be t equal to 2 pi by omega, and omega is how much? Root over k by m. Here the value of k is k, m is m, so you can write omega, and then time period from t is equal to 2 pi by omega. Just divide this 10,000 by t to find out number of oscillations, you will get. So there is a question given: I is equal to, in which there is a long solenoid of radius r is carrying a current in as a function of time. Counterclockwise current is taken to be positive. A circular conducting coil of radius 2r is placed in the equatorial plane of the solenoid, that means in this plane, and concentrating with the solenoid, the current induced in the outer coil. So you need to find out the current induced in the outer coil. So for this one, E equal to, you know that, minus d5 by dt. Just write phi equal to, so you can write mu naught ni. Mu naught n is basically a constant, so minus k d by dt into I you may write kt e to the power minus alpha t. This k you can take out because this is a constant as well. So for this one you may write e to the power minus alpha t. K is a constant, just ignore this one, and plus t into minus t into e to the power minus alpha t. This will be your EMF. Now e to the power minus alpha t and e to the minus t into alpha t. So if you put t is equal to 0, so if you plot this one, value of t is 0 and this t is 0, initially you are getting this is, then you are getting this as minus 1. That means the graph will be starting from the negative position. If you are plotting t is equal to 0, that means the graph should start from the negative position. Now you see the graphs, this graph is starting from 0, this can't happen. This is starting from positive 1, this is starting from 0 again. So this will be your correct answer. Now again, to how to draw the graph exactly. So for exact graph, E is equal to minus e to the minus alpha t. You know that, you know well that e to the power minus alpha t is what? This is your e to the power minus alpha t. This graph is your e to the minus alpha t. And now if you write this one, this will be minus e to the minus alpha t and minus t into e to the power minus alpha t. Now if you plot this one, so this will be the graph of e to the power minus alpha t, and this will be the graph of e to the power minus alpha t into e to the power minus alpha t. As the alpha is not given, so you can't clearly say that the graph will be of this one. So you need to make your decision from this thing only, from the initial position, and by saying the initial position, this you will be, this one will be is your correct answer.